In this video, let's work through some logarithmic and exponential equations. I usually use steps when I work with these, so let's see if we can do it together. For number 34, I always say it this way. If you work with exponential equation, apply log to do both sides. If you work with a logarithmic equation, apply exponential function to do both sides. So I'm going to apply natural log to do both sides. Natural log is a log with the base e. Why? This is convenient, because then this annoying y to the minus 3, y minus 3 in the exponent can finally go down like that. So I'll have 5 minus 3 in front of the log, or basically multiplied by log. ln 5 equals ln 2. My goal is not 5, that's y. My goal is to solve for y. So step 1, apply ln to both sides. Step 2, use properties. Step 3, now your job is to isolate y. Isolate y, or whatever you're solving for, y or x. Isolate the unknown. To isolate in this case, I need to distribute ln 5 into these parentheses, into y and 3. So y ln 5 minus 3 ln 5 equals ln 2. Now identify pieces with the unknown. This is the piece with the unknown. Isolate it. So I want to keep it on the left hand side and everything else on the right hand side. ln 2 plus 3 ln 5. Then I will have y ln 5 equals. I can actually write away, divide everything by ln 5. So I will have ln 2 over ln 5 plus 3 ln 5 over ln 5. ln 5 over ln 5, that's 1. So the answer is ln 2 ln 5 plus 3. And that actually is a number. And the number is, if you use calculator, becomes 3.43. Very nice. Now, let's go to the next example. The number 35 is e to the 8x equals 2. E to the 8x equals 2. 35. And again, I'll just apply natural log to both sides. ln here, ln over there. Well, ln of e, they kind of undo each other, so the answer will be just 8x. If you don't believe me, just take this 8x and put it down. ln e is 1, so 1 times 8x is just 8x. Equals ln 2, and we are almost there. X equals, divided by 8, ln 2 over 8. That's a number as well, and that is approximately 0.09. Very fast. The third example, which is number 36. 17 to the 7x equals 16 minus x plus 6. 36. 17 to the 7x equals 16 minus x plus, let's compare. 17 to the 7x equals 16 minus x plus 6. Okay, perfect. The idea is the same. Let's just repeat what I did before. Applying ln to the both sides usually works right away, unless there's some kind of complication happens. So what I'm going to have now is, I will look at the exponents and put them down just like I had before. Minus x plus 6 go down as well. And by going down, I mean multiply 7x by the natural log of 17, like so. Then minus x plus 6 should be multiplied by the natural log of 16. Remember that we're solving for x. So in this case, I want to collect all the terms with x on the left-hand side. But before I do so, I need to distribute x on the left-hand side. So multiply ln 16 over here. We're going to have negative x ln 16 plus 6 ln 16. Let's collect everything with x on one side. It's going to be 7x ln 17, that's already on the left-hand side, plus, instead of minus, x ln 16 equals 6 ln 16. Now I will factor out x. I will have 7 ln 17 plus ln 16. What does it mean to factor out? Factor out means I will divide by x equals 6 ln 16. X equals, that's the last step actually, 6 ln 16 divided by everything in those brackets, 7 ln 17 plus ln 16. That is the exact answer, which I actually like more. But if we want to know the approximate answer, it should be 0.736. This is the end of the last example with logs and exponential equations. Basically, the idea is very straightforward. You see exponential equation, apply natural logarithms to both sides, and vice versa for logarithmic equations. Apply exponential function to both sides. Then you use properties of the logarithms. Here they are. Sometimes you could even use some properties when you could collect logs with the same base if you want, but I usually don't do it. You end up with a nice exact solution, and then you use your calculator to figure out the approximate solution. Don't be afraid when you see logs. I know you can do it. Just calm down, review the properties, and you'll do a great job. See you in my next video.